Okay, here we have a pressure versus volume graph. Now, at this point in Physics 1, we haven't covered pressure and volume, but we're going to analyze the area under pressure versus volume graph anyway. Later on, we'll see exactly why this analysis is valid. Okay, we have a pressure in newtons per square meter versus volume in cubic meters. Now let's say that we have 4/10 of a cubic meter and a pressure of 120,000 newtons per square meter. Too many commas in here, but I can't really avoid that. And at a volume of 0.8 cubic meters, we have a pressure of 100,000 newtons per square meter. What could possibly be the interpretation of this graph? Well, let's interpret the area beneath the graph. The volume goes from 0.4 cubic meters to 0.8 cubic meters, so that we have a change in volume of 0.4 cubic meters, and that's represented by the width of the graph. The average altitude of the graph, well, halfway between 100,000 and 120,000 is 110,000, and let's designate that here. Now again, as usual, given no other information, we're assuming a linear graph, as we'll see with pressure versus volume. Just as with kinetic energy versus velocity, the graph tends not to be linear. In any case, for now we're going to accept that the graph might well be linear. And we see that we have an average pressure here of 110,000 newtons per square meter. Now let's zoom in just a little bit so we can really see that. And let's see what the area is. Well, the area is going to be our 110,000 newtons per square meter multiplied by our delta V, 0.43 cubic meters, or 0.4 cubic meters, and that's going to give us 44,000 newtons times meters. Now, we know that a newton times a meter is a joule. And it turns out that that's exactly what's represented by this area. Okay, it's the number of joules of work that are done in the expansion of a gas. So if a gas expands from 0.4 cubic meters to 0.8 cubic meters, while the pressure goes from 120,000 to 100,000 newtons per square meter, there are going to be 44,000 joules of work done. And if you're thinking about the proportionalities involved here, and you know a little bit about pressure and volume, you'll see that there's some thermal energy being added here. Otherwise, the pressure would fall a lot more than from 120,000 to 100,000 newtons per square meter. But that's just a little side note in case the interpretation of this situation is worrying you any.